Welcome back to the second episode of our quantitative analysis series in Excel. Hi, my name is Mary. Today we'll take it further by performing descriptive statistics. That means summarizing data so we can understand its central tendencies, spread, and overall shape. There are three categories of descriptive statistics. The first one, which is the measure of central tendency, it entails the mean, median, mode. The second one, which is the measures of dispersion, this entails variance, standard deviation, and range. The third one, which is the shape of distribution, this entails skewness, kurtosis, and histogram. These measures also answer questions like, what's the average score of a certain student, how spread out are the results, and are most students above or below the average? Note, this I'm saying because it's particular to the data set I'm using in this tutorial. You can apply this process to any form of data set. Here I have a data set on students with their mathematics score, their English score, their study hours, and also their attendance percentage. The first category of descriptive statistics we are working on right now is the central tendency, and there we have the mean, median, mode. Using the average function, open brackets, let's say we want to get the mean of the mathematics score, then you close your bracket. I highlighted using Ctrl Shift down and press your enter. So we can see the mean is 71.2, but since we have a whole value of scores here, we can approximate it to 71. This has been well explained in the basic calculations in my previous episode. So the same as median, we use the median function, open brackets, you highlight. Let's say we want to get the median of, I'm basically using the math for right now, but you can use any one of your choice. Okay, I'm thinking of doing something. Let's do this for every of the data we have here: math, English, study hours, and attendance. So let's also replicate this. To replicate this, guys, all you just need is to ensure that there's this small tiny plus sign and you drag it to whichever cell you want the same function to be replicated in. What you just do, you can see, guys, this has replicated itself. We don't need to by ourselves start inputting the functions. Do you guys just see what I did? Let me redo for you. Since we can see that math, English, study hours, attendance, and this is also arranged in that order of math, English, study hours, and attendance. So in order to replicate this formula, but telling Excel to use the individual cells of English, study hours, and attendance for us, we will just click on this tiny plus sign here and then drag it. Can you guys see what I did? I pressed down my left key and I dragged it from here to this place. Now you can see that it has replicated the function for us even while inputting the correct cell, because we arranged this heading the same way it is arranged here. Do you guys see now? Yes, so let's do the same for the median. Yeah, so this we don't need to start rewriting each formula for each cell. Let's proceed to mode. Modes check for repetitive value, like if a certain value is repeated in a column or a data set. There are two different functions you can use in Excel. We have the multiple mode and the single mode. The multiple mode returns every number that is repeated in a certain column, while the single function returns only one. I want to check all the repeated values in this column, that means in the mathematics column. So to do that, I'm using the multiple function, but let me show you the difference by using the single function first. You can see, guys, this is showing us only one. So let's check if we have multiple repeated values in this math scores. So to check that, we change this to multiple. Excel returns all the repeated values in this file for us. This, you can also do the same for this. Amazing, right? So here, so we can see the repeated attendance, the repeated math scores, the repeated English, and all have you. Even if you want to proceed forward in finding certain things using this, you can also do that, but we're not doing that currently in this tutorial. We are proceeding to the second category in descriptive statistics, which is dispersion. Under dispersion, we have the range, standard deviation, and variance. We have the range, standard deviation, and variance. Range gives us the difference between the highest and the lowest score. So if we want to get the difference between the highest math score and the lowest math, this is how to do it. We use the maximum minus the minimum. You can also do this for math, English, study hours, and attendance. So we'll just copy this and also paste it here. Press your equal to maximum, you highlight this value, minus, use your subtraction sign, minimum. Once that is done, you close your bracket and you press your enter. So here we can see the range of math score, which is 45. So we can, just the same way we did the other time, you can replicate this for the individual cells of English scores, study hours, and also the attendance. Here you can see our results, guys. Can you see? This is so amazing. So also for standard deviation in this data set, now relating to this data set, shows how spread out the math scores are from the average, which is the mean. Do you guys understand? So a small standard deviation means that the numbers are close to the mean. That means there is less variation in the mathematics score, while a large standard deviation means the numbers are spread out far from the mean, which is that there is more variation in the math scores. So if there's a small standard deviation, that means the student scores are not very different. But if there is a large standard deviation, that means that the student scores are very different. Like there's a wide gap, there's a wide variation. That means a certain student can score 45, another one is scoring 65 and all. Now let's apply the standard deviation function. Excel represents standard deviation as STDEV, open bracket. And also you can see there are two different functions here. We have the .p and the .s. .p is used when we want to calculate standard deviation based on the entire population. So let's say I want to get the standard deviation based on this entire value. That is when I use the .p. But I will use the .s if I want to find the standard deviation of only the mathematics score. We'll be using the .s, then I will also show you the .p so we can identify the difference. I like the math score. Yes, so we can see that the standard deviation is 14.20, approximately 14.21. This shows us that there is a large standard deviation between our scores. That means there is more variation between the student mathematics score. Let's also replicate this for others. Wow, so we can only see that the study hours has a small standard deviation, which means that there is low variation in the study hours of students, but we can see that there is high variation in the mathematics, English scores, and even the attendance of the students. So let's imply standard deviation for the whole population now. This is how we do it. Let me write for population here. So remember, we use STDEV.P now, since we are using for the entire population. So you highlight the entire range. So this we want to use to check how spread out is this result, this entire result of the student. Press your enter. Wow, 32.5 is a lot. Actually, it is a very large standard deviation. This shows us that there is high variation, that there is much variation between the informations of every student. Next on, we have variance. Variance measures how far the mathematics scores are from the mean score. Variance also is the same as standard deviation, but how variance is different is that variance squares the differences. And you can see here also, just the same way as standard deviation, we have the variance of population and variance of a specific sample. So right now we are working with the variance of a specific sample, which is .s, open bracket. Then you click on the math scores, you highlight the data range, close bracket, and press your enter. You can do the same for this. Also, if you want to get the population variance, equals to var.p, open bracket, the entire data set, highlight it, close your bracket, and press your enter. So that gives us the answer. Let's move on to the next category of descriptive statistics, which is the shape of distribution. And we have two different ones, the skewness and the kurtosis. We also have histogram, because histogram visualizes charts. It shows us chart version of the spread of or the shape of our data set. In the next episode, I'll be showing you how to delve into frequency distribution and creating of histograms. Right now, we'll be working with skewness and kurtosis. Thinking to broaden this so that you guys can know. Yes, let's even do something. Yes, so we'll be dealing with skewness and kurtosis. Skewness tells us whether our data leans to the right or to the left. Let's say you cut out a cake. You want to check if the cake leans more to the left or more to the right. So by this, I mean we want to see if more students scored below average or they scored above average. Excel represents skewness as SKEWQ, open bracket. Also, before you proceed, you can see it brings out two different functions. The skewness .p is based on an entire population. So if you want to get the skewness of this entire population, that is when we use the dot P. So just remember that P means population, S means sample. Highlight the math score, close bracket, enter. So let's also include the headings the same way we did earlier. Let's ensure it is this tiny plus sign. You can see we have 3 different plus signs represented here, guys. Can you see this big plus sign, this one with arrow, and this tiny one? That is the one you use to drag, and you press down your left key and drag. If our result is greater than 0, that means the skewness is positive. But if our result is lesser than 0, that means our skewness is negative. Positive means that most student scores are lower than the average, while negative means that less student scores are higher than the average. In the math score, we can see that this is greater than 0. This means that it is a positive skew, and most of the student math scores are less than the mean, which is 71, while just a few have higher than 71. The same here, you can see also in the English scores, we have a positive skew, just the same way I explained. Also in the study hours, we can see that most student study hours is lower than the average study hour, which is 6. So that means most students study less than 6 hours, while just a few study higher than 6 hours. So here our attendance, you can see the attendance is negative. That is negative skew. This means that most of the students attendance percentage is higher than the average, which is 83, but a few of them have low attendance value. Assuming we have a 0 return, that means that the data is roughly symmetrical, meaning that it is a normal distribution. It is not leaning to one side than the other side. Next one is kurtosis. Kurtosis tells us how the data looks at the top, which is peak, and at the end of the distribution. Same way I used a cake example the other time. Think of it as whether a cake is super tall and pointy or whether a cake is wide and flat. Kurtosis is represented as equal to KURT in Excel. You open, highlight the data range and close your bracket. Right here we have a negative result. Let's also highlight it for the English study hours and attendance. Have all negative. This means that the performance of the students was spread out more evenly with fewer extreme outliers compared to a normal distribution. That means we have few students that had lower scores, while we have few students that had higher scores than the mean. Doing this helps to know if you can use your data set for parametric tests. These formulas give us a full summary of our data set. For example, if the mean is much higher than the median, that means the data is skewed. Also guys, there's an inbuilt Excel add-in that enables us to do descriptive statistics without writing a single formula. It is Excel Data Analysis TOOLPAK. Right there, you go under your data tab menu. Here at this left towards the right hand side, you can see data analysis. In case you don't have this on your own Excel and I want to trust that you are using the latest Excel version, come here under the developer, you click on it, and you can see under add-in, you click on this Excel add-in. You can see analysis TOOLPAK, analysis TOOLPAK VBA. You only need this analysis TOOLPAK, or you can click on both and click on OK. Then you come back under your data tab, you will be able to see your data analysis here. So let's proceed to using this for our descriptive statistics. You click on this, give it time to load, and you can see different analysis you can do here. Guys, stick to the end of this quantitative analysis series. I'm going to show you a lot of things, a lot of analysis you can carry out in Excel, different ways to actually do them. So right now we want the descriptive statistics. You click on only the descriptive statistics and you click OK. Now this brings us input range. So our input range, we highlight every of this information. You can notice I highlighted this with the headers. So here you say labels in first row, which is headers in first row. Since this is our header and it is in the first row, you ensure to click on it. And then you can see columns and rows. We want this to be by columns and not by rows, except you want Excel to find the descriptive statistics by each student. That is when you find rows. We want it to be the overall student scores of math, English study hours. Do you understand? You want it to find the descriptive statistics of each student. That is when you use the rows. But right now we want it to be in columns. That means for math, English study hours. You will see by the results right now. So once this is done, you also want to click on summary statistics. If you want it to bring out the confidence level, the case largest, the case smallest, either anyone you want, you can highlight this in this interface. Then once this is done, you press press your OK. And now guys, you can see everything we've been doing since in Excel. This has brought it all out for us. So here you can see the mean of the mathematics, the standard error, the median, the mode, standard deviation, the sample, variance, the kurtosis, the skewness, the range, just everything I've showed you guys. Are you excited about this? You can compare. Let's check the mean of math score is 71.2. You can see just the same thing we got. Yes, I did this just in case you don't have this TOOLPAK, so you will not be limited. You can still do your quantitative analysis without having this TOOLPAK. You understand? But that is all, guys, and I hope you really learned a lot. You can see here, this is just a summary, and this is really amazing, guys, and I hope you really learned a lot. Please don't forget to subscribe. I'm sure you learned a lot from this tutorial. Please guys, subscribe, as this helps me to know that you guys are enjoying the tutorials. Thank you so much. Please don't forget to subscribe. Thank you for watching, and I'll see you on the next episode on frequency distribution and creating of histograms. See you on the next one, guys. Bye.